Troy Hudson, this is my partner Mike, and we did experiment 8 on the pH titrations. A little introduction. Our objective was to generate the pH profiles for strong acids and weak acids with a strong base. And the pH profile is a graph showing the change in pH of a strong or weak acid when a strong base is added. And for an unknown acid, we were to determine the pKa, Ka, and the molecular weight of an unknown weak acid. And the titration is a slow addition of one solution to a known concentration of a known volume of another solution of an unknown concentration until the reaction reaches neutralization, often indicated with a color change. A little bit of background. Neutralization is adding a base to an acid solution. And for the strong acid with a strong base, the pH only depended on the concentration of the strong acid at the beginning. The pH would slowly change as you added the strong base. For the weak acid with the strong base, the pH depends on the Ka value of the particular acid. And the endpoint is visually seeing a color change when adding a strong base to an acid solution, and this is where neutralization occurs. The equivalency point was the ideal point for completion. And the endpoint, the lighter color is a good endpoint because it means you reach it neutralization, and the bad endpoint is dark pink because you added too much of the strong base to the solution. And the materials, we used a pH meter, which was an electronic device used to measure the pH of a liquid, and it consists of a special measuring probe called a glass electrode, a small beaker used to hold the acid solution, and a burette was used to dispense a solution to another chemical solution. And for this experiment, we used it to dispense the strong base into the acid. And we used a magnetic stirrer to stir the solution, and you put a magnetic stir rod into the solution, and when you turn on the magnetic stirrer, it stirs the bark rapidly to ensure that the solution is stirred.
Okay, so for the apparatus setup, which was all was used as the materials that Troy just described, and this right down here is the magnetic stirrer, and the flask was placed on top of that, and the acid solution was placed inside of the flask, and the stir bar was placed inside of that, and then it was turned on to stir it up, as Troy said. And then the burette was placed in a clamp stand, and then the NaOH was placed inside the burette to be dropped into the acid solution. There was 3 parts to the experiment, and each part was done the exact same way, like the procedure was the same, except there was different acid solutions used. So I'll first describe just how the procedure kind of went, and then I'll talk about each different part. The procedure, first you put 10 milliliters of the acid solution into the beaker or flask, and then the pH meter was placed inside the acid solution, and water was also added to make sure that the pH meter wasn't touching the bottom. The initial pH was recorded, and then the burette was filled with the NaOH, which was a strong base, and then you added the NaOH to the solution by increments of 1 milliliter, and then the pH was recorded after each time. The NaOH was added until the pH increased by 0.2 pH units, and we kept adding the NaOH until it passed the equivalence point. And then once you passed the equivalence point, you just kept adding until the pH turned to 12, and then you could stop. So for the first part, it was the strong base and the strong acid, and then the strong acid was HCl, which is hydrochloric acid, and the equivalence point was, as you can see right here, whenever the pH is about 7, and there was a jump in the pH where it went from, it was about 12 milliliters of the NaOH was added, and then it jumps to, the pH was 11, or I'm sorry, it was like about 4.9, and then the volume, the pH jumped to like 9.37, so that's whenever you pass the equivalence point for part 1. For part 2, it was the strong base weak acid, and this was acetic acid or CH3COOH. And the equivalence point this time was right here, around 13 milliliters added, and this was a little higher than the strong acid because weak acid isn't as strong, obviously. Then part 3 was the unknown, and me and Troy both did an unknown, but for this purpose of this presentation, we'll just be talking about mine, which was unknown number 15. And the equivalence point for this one was right here, and that was like around 10 too. And for each parts, the HCl had a molarity of 0.1, and acetic acid had a molarity of 0.12, and then the mass of the unknown was found to be 0.205 grams. And then for the data interpretations, I just have the unknown acid part. Troy, you have the other parts for this, I think. But I'll talk about the unknown acid first. The pKa was found to be 5.1, and the molar mass was found to be 200.03 grams per moles. And the unknown identity was potassium hydrogen phthalate. I think that's how you say it. Yeah.
These are just the balanced chemical equations for the strong acid with the strong base, and the strong base with the weak acid. And for the conclusion, I asked why we didn't find the pKa or Ka value for hydrochloric acid. And that is because hydrochloric acid is a strong acid, so it doesn't affect the pH of the solution, so we don't need to find the pKa or the Ka values. Asked to compare the initial pH of hydrochloric acid and acetic acid, and the hydrochloric acid was lower than the acetic acid because hydrochloric acid is a strong acid and acetic acid is a weak acid, so the pH will be lower for the strong acid. And comparing the equivalency points of both, the equivalency point pH of a weak acid will be above 7 because it will convert to its conjugate base at the equivalency point. And comparing the number of moles required to neutralize, the hydrochloric acid needed less base to neutralize it because it had a lower concentration than the acetic acid. The hydrochloric acid was 1 mole and the acetic acid was 1.2 moles. And here are our references, the lab manual and the assignment book.